My name is Hassan, and I am a part of Zaritra Kathy Bank as a IT Finance Manager. Today, I'm very excited to share a dashboard which I have prepared for 365 Business Bank. 365 Business Bank is merely a banking institution which has been providing banking services to its various customers. Before diving into the dashboard, let us view the data sets which they have provided and the problem statements for analysis. So we are here and we are viewing the data. So the first data which they have provided is the car data, and if we open the data set, yes, these are the features of the data set in which they have provided a card ID, client ID, card brand, either it is a Visa or Master or maybe other, card type, credit, debit or debit prepaid, card number, expiry date of the card, CVV, either it has a chip or not, number of card issued to the client, credit limit assigned to the card, and account opening date, and the last year in which the PIN has changed. So view let us view another. So let us view the another category of data set which they have provided, which is MCC codes. MCC codes is nothing but the merchant category codes in which merchants categories are has been displayed. So let's view another data set. This is the transactions data. Let's analyze the features of transaction data. Uh, it's the transaction ID, date of the transaction, client ID, card ID. Client ID and card ID as the foreign key in transaction data. Amount of transaction, chip, you either it is a chip transaction or not, merchant ID, merchant city, merchant state, zip code, MCC code, or merchant category code, or either error occurred or not. If error occurred, then there is a type of error which they have provided there. So last but not the least, they have provided the users data. Come on. Yes, they have provided a user ID, age of the user, retirement age, date of birth, sorry, its year of birth and month of birth, gender, their address, latitude, longitude, per capita income, yearly income, total debt on that uh, customer, credit score of the customer, and number of credit cards issued to the customer or user. So let us view the problem statements which they have provided to us. So yes, this is the problem statement. Basically, they want insights. They have showed the areas in which they want us insights. Customer demographic segmentation, transaction volume and temporal analysis, MCC category spending analysis, geographical and transaction distribution, card usage and performance analysis, chip transaction effectiveness, error anomalies, investigation, income versus spending behavior analysis, credit score and transaction relationship, debt burden and spending patterns, card life cycle and renewal trend, multi-card ownership and loyalty analysis, merchant performance and partner evaluation, fraud and security risk monitoring, real-time integration analytics dashboard. So now it's time to dive into the Power BI, in which I have prepared a dashboard for 365 Business Bank. Let's go to the dashboard. So I'm on my dashboard, and this is the home page of my dashboard. Let's get inside. This is the average retirement age, which is 66. This is average yearly income, total yearly income, total transactions. Transactions are basically the spendings of users. These are the merchant cities in which users have spent it, and these are the categories of MCCs, top five categories. We can see that money transfer is about zero point 0.6 million, and this is the gender wise average total debt. Green portion highlights the male population's total debt. So this is the top five merchant states, and we can view that these all are the part of United States of America. Let's start. This is New York, Florida, Texas, and this is maybe California. Now these are the buttons and the timeline trends of this is the timeline trend of error. We can see that error occur normally from 6 a.m. to 6 p.m. and their peak is from 12 p.m. to 3 p.m. So yes, city. This also highlights that merchant cities number of transactions in the merchant city at 6 am it's about 34, and then they have spike, and after 9 a.m the spikes down. Then we move to the states. This is the states analysis of transaction, the amount of transactions involved. This is the MCC categories, count of MCC categories. So this is all about my homepage. I have a slicer pan there in which gender, city, state, and merchant category codes are the slices over here. So let's dive into the page one, or maybe the problem one. So this is the problem one, which is customer demographic segmentation. Uh, let's dive into the insights. This is the average age of users, which is 45 years old, average retirement age, which is 66 years old, total yearly income, which is 91 million, and this is total debt, which is 127 million. Average credit score of users is 710. Average total debt is 64,000, while the average per capita income of users is 23,000. Uh, this graph shows the average age of users of both female and male population, as the average age of male population is around 45 years old, while the average age of female population is around 46 years old. This is the age group wise average debt chart, in which we can see that the after 40s the average debt of male population has increased, and then after 60s it decreases. For the credit score, let's see, the credit score of male population decreases after 50s, and the female population increases after 50s. The income, basically the income shows that age group after age group of 30s male population's income increases, then after 50s it also increases, then decreases to 60s. This is the sum of amount by description and gender. Description is basically the merchant category code, in which we can see that the more male population has spent more money on money transactions, and the female population has spent more money on grocery store, supermarket. So this is the gender wise and age group wise credit card holders. As we can see that from age group 18 to 30 has more credit cards than other age groups. This matrix shows the gender and age group wise average income. Average income of population has decreased after 70s. So that's all for the problem one. Let's dive into the problem two. So this is the problem two, which is transaction volume and temporal analysis. So this is the transaction count, which is 157,000, and this is the transaction volume, which is 7 million. So this is the trend. day wise trend of transactions. So is the timeline of transactions. Let's jump to the errors. This is error timeline of errors. We can see that from 2022 to 2024 the count of error reduces. This is the timeline of transaction. So from 6 a.m. the transactions get spikes in upward direction. Similarly, if yes, uh, this is the timeline of errors. Mainly errors from 12 p.m. to 6 p.m. we can observe a spike in the errors. Now let's view the problem 3. So this is the problem 3, which is MCC category spending analysis. These are the top 10 MCC by spending, in which money transfer has the more volume over share, and then the top 5 MCC by online spending. Uh, Through online, users have spent it on more on tolls and bridges, free telecommunication, utility, electricity bills, cable, satellite, and other paid television services. So these are the least 5 MCCs by spending, and these are the slicers, year-wise slicers and month-wise slicers. Let's dig into the data of March. This is the position of March. Uh, if we select an year 2023, this is the data of 2023 March. So we can see that the groceries in the stores volume has increased in March 2023, and other things are remain same. So that's all for the problem 3. Let's dive to the problem 4. So this is the geographical transaction distribution, which is a problem 4. So let's dive into the location. This pie chart shows the top 5 MCC by region. MCCs are the merchant categories. So let's zoom into the data set. These all are United States of American states. Now drill through towards the city level. Let's view the city level score. Oh, that's so much bubbles. We can see there are a lot of bubbles from European countries. So the data set has the cities of Europe as well, and it can also be observed that the eastern states of United States have more transactions than the western states. So that's all for the problem 4, and now let's dive to the problem 5. Yes. So this is the problem 5, which is card usage and performance analysis. So this chart shows that the card brand by transaction in dollars. So number of transaction or spending by using a card brand, in which we can see that the debit card of Master has the more volume, which is around 2.4 million. So this is the credit limit by card brand, and Visa card has the more credit limit. This is the timeline which shows the pin change by year, and in 2011 there's 809 cards which have changed their pins. After that, in 2020, 1208 cards have changed their pins. This chart shows the card type by error. Debit card of Master has the more error count, which is 1088. Now this is the expire by year. So large number of cards has been expired in 2022, and this is chip and card brand by credit limit, means either the cards has chip or not. So Mastercard has a credit limit of 42 million when it has a chip. So that's all for problem 5. Let's dive to the problem 6. This is the problem 6, which is chip transaction effectiveness. So chip wise error, either the card has a chip or not. So there are 2453 instances in which the error has been detected if a card has a chip. This graph shows the volume of transactions in which chip cards has a chip, which is 6.15 million. So the chip type wise transaction, there are three types of chips: chip transactions, swap transactions, and online transactions. And chip transaction has the more volume, which is 4.64 million of transactions. Similarly, this is the matrix which shows that the chip type wise transactions, either it is a error transaction or not. So 1818 transactions are detected as an error transaction if while using a chip transaction. So now let's move to the problem 7. This is the problem 7, which is error and anomaly investigation. Now we have to deeper dive into the errors. Uh, while using online transactions, insufficient balance occurs in 159 times, and bad card number occurs 97 times. Then we have jumped to the monthly error trend, in which let's see, in month 10th or October, 10 types of error occurred, in which bad card number occurs 5 times, bad CVV number occurs 10 times, bad expiration 6 times, bad pin occurs 35 times, technical glitch occurs 36 times, and insufficient balance occurs 142 times. After 10th month or after October, uh, their counts decreases. So these are the top 6 error categories by counts, and insufficient balance occurs most. After that, bad pin occurs. Hourly error trend. It uh, These are the top 3 types of errors, excluding including insufficient balances. So let's see. This is the bad pin, which occurs from 6 a.m. to 6 p.m. That's all about the errors. This is the problem 8, which is income versus spending behavior, in which I have tried to establish a relationship between income and spending and per capita income. This chart shows that the relationship between per capita income and amount of spending. This shows that when we increase the average per capita income, the amount of spending also increases. Correlation coefficient of this relationship is 0.47, and the r square is 0.22. uh, Least r square shows that this model is not enough significant, so it it should include more variables to improve R square. Similarly, in regression between yearly income and amount, we can see that the average when average income increases, then average amount of spending also increases. uh, this is the correlation coefficient of this relationship, which is about 0.55, and this is R square, which is 30%. So this is the relationship. Now let's jump to the problem 9. So this is the problem 9, which shows the relationship between credit score and transaction relationship. uh, it shows when the uh, credit score reached about 700 or 674 to the 800, then the number of transactions also increases. Further, these are the top 7 error categories count by credit score. There is a relationship between error and spending, where the transaction volume count of volume increases, then the error occurrence also increases. So these are the types. Insufficient balance occurs the most, then bad pin uh, is the least, and bad CV has touched to the baseline. So this is the trend between error and credit score. So let's see the problem 10. This is the problem 10, which is debt burden and the spending pattern. uh, so there's an average amount of spending. It shows that the debt increases, the average amount of spending also increases. This is the trend line, which shows the upward relationship. This is a regression between the debt and the average spending, and average amount of spending increases when the debt increases. So the correlation between them is about 0.34, and R square is 0.11. So let's move to the other problem. The problem 11, card life and renewal trend. This is the card life and renewal trend. This chart shows the count of expires by the group. In 2021 and 24, 3.72 3,720 cards has been expired. Year wise pin change count in 2021 and 24, between 2021 and 24, large number of pins has been changed. This is the matrix between year wise card brand with expire count. Large number of the counts has a large number of the cards has been expired in 2021 and in 2024. Card issued by card types, about 5,256 cards have been issued for debit cards, as a debit cards. Account opening by account trend, number of accounts open in the spike in 2019 to 2022, in which number of accounts open has been increased. This is the problem 12, which is multi-card ownership and loyalty analysis, in which card issued by type chart shows the regression between number of cards and the average amount. It shows that the number of when the number of cards issued to the cardholder has increased, then the average amount of spending also increased. The relationship shows the correlation coefficient of of about 0.86, and the R square is 0.74, which is a very good model. This matrix shows the year-wise card brand with expire count, and this is the correlation coefficient, number of cards with average spending, year-wise card brand with expire count. This is sum of amount, this is average amount. So let's have a view of the next problem. So this is the problem 13, a multi-card ownership and loyalty analysis, in which I have a bar chart race month-wise and year-wise for each category, in which we can analyze that the volume for money transfer is the most. Then we have observed that grocery stores, supermarkets, and wholesale clubs volume increases at the start of month and at the end of month. Service stations bills increases further. Utility bills, electricity, gas, and water sanitary bills, they moves quarterly in an year. So that's all for that. Now let's jump to the problem 14. So this is the problem 14, which is fraud and security risk modeling, in which I have analyzed that most of the count of errors has been occurred between 6 a.m. to 6 p.m., in which there is a spike between 7 a.m. to 3 p.m. A large number of bad pin counts occur between this 7 a.m. and 3 p.m. So I have investigated that which age group has occurred the most bad pins, which it has been seen that from 31 years to 60 years bad pin error occurs the most. And at the credit score we can observe that from 650 credit score to 750 bad pin occurs the most. Error by chip type shows that the chip transaction and swap transaction has bad pin error, but online transaction don't have any bad pin error. So this is the target age group, which is 30 from 60, to avoid bad pin error. So that's all from my dashboard. Uh, so that's all from my side. I have tried my level best to analyze the user data, transactional data, merchant category data, and card data to formulate fruitful insights which can be useful for taking measures. So that's all. Thank you very much.